Simplify the expression. So I can see that they're being multiplied, so I'm going to refer to as FOIL, front, outside, inside, and last. I'm going to start with multiplying the fronts. 2 times -6. There's 1 negative, 1 is odd, final answer is negative. Outside, 2 times 4 is 8, and attach the I. A positive times a positive is a positive. Inside, 1 times 3 is 3. There's 1 negative. 1 negative is 1 is an odd number. Final answer is negative, and attach the I. 1 times 4 is 4. There's no negative, so it's positive, but I do have 2 i's. That is an I squared. Okay, here we go. So I'm going to combine like terms. I owe 4 times -1 is -4. And when I combine a -6 and a -4, I end up with a -10. +8 and -3 is a +5, I. Complex number, there's the real portion and there's the imaginary. Simplifying this expression, which is subtraction. So here in the first parentheses, now when I distribute this negative, I end up with a +3. 2 negatives make a positive, and most students forget to distribute it to the second term. A negative times a positive is a negative. Now I'm going to combine like terms. 2 and 3 is 5, and 1 and -4 is -3, and attach the I. This is complex, the real and the imaginary. Simplify C. I will need to use algebra that involves multiplying by the conjugate of the denominator. If you missed class, you can refer to this video. I believe it is lesson number 5. The conjugate means I write the first and the last term, but in the middle I switch the sign. So it was positive, and now it becomes negative. And I'm going to FOIL the front, or the top, and I'm going to FOIL the bottom. So here we go, multiplying the fronts. -3 times 2. Outsides, negative times negative is a positive, so +3i. Inside, 8i. And last one is -4. And I could write I squared, but I'm going to put a -1 because I know that I know that I squared is equivalent to -1. Once again, front, outside, inside, and last. And I'm going to go ahead here and simplify. So I can combine these two middle terms to have a 11i. A negative times a negative is a positive, and when I finalize, I get -2 plus 11i. Now that's the numerator. That's the numerator. We need to still find out what is the denominator. Now, the denominator is a little bit easier to do. If you remember when we said do FOILing, you get to cut out when you're multiplying conjugates. I get to cut out the two middle operations. So I get to multiply the front, that's 4, and then multiply the last, so 1 times -1, and an I squared. And remember that I squared is equivalent to -1. So a negative times a negative is a positive, and 4 plus 1 is 5. There's a numerator and there's the denominator. If it would say to write in standard form, this 5 has to be shared with both the left and the right. Complex solution, this is the real, this is. Find the solutions, and that means where do these two parabolas cross? Is it in no location? Is it in one location? Or two locations? And remember, every location that they do cross is going to have both an x and a y component. Now, since they're both already set equal to y, this is going to be a little bit easier for us. We're going to write down the first one, and I get to set it equal to the second. And there's no right or wrong. I'm going to move everything over to the side that has a larger leading, leading coefficient, since they are both the same degree. Remember, when this moves across the equal sign, it changes signs, moves across, changes signs, moves across, and changes signs. Now you have nothing left on the right. On the left, when I combine like terms, 1x squared, positive 6x, and -16. We're asked to find the solution. So at this point, the only variable you see is an x, so we want to solve for x. As a reminder, we could try factoring, it may work. Quadratic formula and completing the square will always work. Now, why do I take time to try factoring? Because it's the easiest of the three. If it doesn't work, then I'll choose one of these two methods. What multiplies to equal negative 16 and combines to give you positive 6? Is there a combination? 1 and 16, no. 2 and 8. Well, 2 and 8 would work if 8 was positive and 2 was negative. Multiplies and combines. X minus 2, x plus 8. Leading coefficient is 1, so I don't have to worry about doing bottoms up. The reason I like this method is because there's one solution, 2. There's another solution, negative 8. Remember, it switches signs. Most students stop here because they're used to getting, okay, I got the solutions, I'm done. But remember, when we think about this as a graph, this says that the two parabolas are going to cross in two places. They'll cross when x is 2 and x is negative 8. We need to know what is the corresponding y that goes with 2 and the corresponding y that goes with 8. So most students forget what's that y and what's that 8. I often suggest students plug it into decimals. Use decimals as a calculator. Could you use mental math? Absolutely. For instance, you go up to one of the two original equations. So I'm going to write down one of the two. There's no wrong answer. When I input a 2, wherever I see an x, what do I get for an answer? So I have 2 squared plus 4 times 2 plus 8. 2 squared is 4. 4 times 2 is 8. 4 times 2 is 8 plus 8. And I know 8, 8, and 8 is 24. I'm going to replace this question mark with 24. Now negative 8, much larger number here. When I substitute a negative 8, I know negative 8 squared is 64. Negative 8 times 4 is negative 32 plus 8. I put an input value of negative 8, and now I'm looking for the output value, the y. 2 times 64 is 128 minus 32 plus 8. So I'm just going to grab a calculator quick and plug in those numbers to save myself time. 128 minus 32 plus 8 is 104. My output value is 104. 104. Those are my two solutions. These are the exact points where the two original parabolas are going to cross.